Welcome to homework.
So here, for part A, we need to, of course, draw the free body diagram for each block. So we can draw the M sub B first. Going up would be force tension. Going down would be mass of block B times G, so essentially the weight. Going up would be the displacement in the y direction for block B. So we're going to say upwards is positive. For the second block, we have perpendicular to the surface of contact, force normal. Going straight down would be M sub G, or rather M sub A G. This would be our angle theta, and then going straight to the left, this would be force tension. And so we can say that the sum of forces in the y direction for block A would be force normal minus M sub A G cosine of theta. This would equal 0. We can say force normal would then be equal to M sub A G cosine of theta. We can say that sum of forces in the x direction for block A would be equal to M sub A G sine of theta. And then minus force of tension, this would equal the mass of A times the acceleration of block A in the x direction. We can say that the sum of forces in the y direction for block B would be equal to force tension minus M sub BG. This is equaling M sub B times the acceleration of block B in the y direction, and therefore force tension would be equal to M sub B times G plus the acceleration in the y direction of block B. And so we can say that since the blocks are connected by a cord, the acceleration of block B in the y direction would be equal to the acceleration of block A in the x direction, and this would simply be equal to A, the acceleration. Let's substitute the expression for the tension force into the last equation, let's substitute this equation, rather, into the equation for block 1. So we can say that M sub A G sine of theta minus mass of B times G plus A would be equal to mass of A times A. Therefore, mass of A G sine of theta minus mass of B of G would be equal to mass of A times A plus mass of B times A. And we find that the acceleration is going to be equal to G times mass of A sine of theta minus mass of block B divided by the total mass M sub A plus M sub B. This would be your formula for the acceleration for part A. Now, for part B, however, if the acceleration is to be down the plane, it will be positive. So if A is down the plane, A is greater than 0. And this would happen if M sub A sine of theta is greater than M sub B. Now, if it's up the plane, if acceleration is up the plane, this means that the acceleration is less than 0, and M sub A sine of theta is going to be less than mass sub B. Again, this would be for up the plane, this would be for down the plane. If M sub A sine of theta equals M sub B, then we know that the acceleration is going to equal 0 meters per second squared, and the entire system will either be moving at a constant velocity or be completely at rest. That is the end of the solution. Thank you for watching.